So I'm Miles. I work for Google as a developer advocate, focused on Node.js and the Node.js ecosystem. Also work on our internal products and our different teams who are working on cloud products for Node. At the bottom of this, I get to use my laser pointer for this, which makes me really happy. This little bit here. You know, the opinions are my own. They're not my company's. If you're giving a talk at a conference, just throw this slide in there unless you're like legitimately talking about your company stuff. Not a lawyer. I don't know if it actually works, but so far I haven't gotten in trouble. So I thought I'd start this talk with a bit of a glossary. There's a lot of terms I'm going to be throwing around, and I think it would be good to kind of build a shared language. I think just for collaboration in general, this is really important, because if I'm saying something and you think I'm saying something different, we're not going to agree. So we're going to start with ESM, which is ECMAScript modules. So you may know this as the import and export syntax that you probably use with Babel. You might use inside of the browser. You're probably not using a lot with Node today, but you can. We'll talk about that. But whenever I say ESM, I'm referring to ECMAScript modules. CJS is Common.js modules, and you may know this as require or module.exports. This is the syntax that you're used to from Node.js. So every time I say CJS, Common.js, ESM, ECMAScript modules. Cool. The next one that we have is interoperability, and this is the ability for ESM modules to bring in CJS modules, or for CJS modules to bring in ESM modules. You know, we have this whole massive ecosystem of Common.js that we've been writing and maintaining for years, and we're going to want to use that in the new ESM world, and vice versa. When Lodash converts to being written in ESM, you're going to want some sort of way of bringing in the latest version into the code that you're currently writing. Transparent interoperability. This is the ability to do so without having to be aware of it. So if you were able to, for example, import a module, and it just worked, whether or not it was ESM or CJS. Or vice versa, being able to require a module and not have to know if it's ESM or CJS. We'll dig into why this is particularly complicated, but when I say transparent interoperability, this is the particular definition that I'm referring to. A goal is a pairing of a top-level grammar and a top-level execution mode. It is both a combination of how the runtime will execute your code, as well as the syntax that is available to you. We'll dig a bit more into what a goal is later. A specifier is a string that the runtime will use to locate a module. So when you import Lodash or import /module, that string, I think it's kind of legible right here, that string is the specifier. Specifier resolution is the algorithm that we use to convert a specifier into a path to a module. And that's kind of a hand-wavy definition. It's not perfect, but it's enough right now to kind of explain. It's possible that a specifier would be resolved into an object or into lots of other things. But when I'm talking about specifier resolution, I'm talking about like, how do I take a specifier that you've been given in a statement and turn it into a path somewhere so we can get the source text that we need to execute. Bare imports. So when you have a specifier that does not start with a relative or an absolute path, that's a bare specifier. So require underscore, import Lodash, require express. Node knows how to deal with these. It can look into the Node modules folder. The browser doesn't. We'll dig into that. And finally, existential dread. And this is the feeling I get whenever I try to figure out how to do all this stuff. And so like a good place to start is kind of how did we get here, and just going to be a really quick history of modules in JavaScript. And ES4 introduced the concept of packages, and if many of you know the history of ES4, you'll know that this is not a story that ends well. But the original implementation was similar to C++ namespaces, and the intent was to create something like the Java jar system. It was ripped out of the standards track and never seen again. Not just the modules, but ES4 altogether. It's the JavaScript that never existed. Common.js was then introduced with various members of TC39 working on it. It was not done through a standards track, though, and it was intended specifically for server-side JavaScript. When Common.js was developed, it was not made with the intent of running in browsers. A lot of what goes on with Common.js, with how we're handling things on the file system, just doesn't scale to a system where you need to be worrying about network traffic. Node.js implements a variant of Common.js, and that is what many of us are used to using for modules for many years, I guess for almost a decade now. And let's not forget about AMD. AMD was only spec'd by require.js. It was more of a convention. AMD stands for asynchronous module definition. And because of AMD and because of CJS and all these different things, we had UMD. Anyone still use UMD anymore? Nope, didn't think so. Oh, in the back. OK, cool. Thank you. UMD was a way of wrapping code so that any module environment could understand it. So it was lots of if statements, like if there is module exports, then export it this way. If not, if it's written by machines, not by humans. But ESModules landed in ECMA 2.6.2 in 2015. We're now in 2018. It's taken some time, but it's currently shipping in the majority of modern browsers, and there's an experimental implementation in Node. And you can use that experimental implementation in Node today with a flag. That flag is -- experimental modules. So if you're using Node 8 or Node 10, run Node with experimental modules, and you'll be able to use ESM right now. There are some specifics to our implementation, though. One is expected to change at any time. So it's part of the reason why it's experimental. It's why it's behind a flag. We have not settled on the particular semantics of the implementation. So be careful about shipping this stuff to production. I'm a sign, not a cop. I won't tell you what to do. But just be careful and realize it may change from under you. There is support for named exports for core modules. So this is really great. So if you're trying to import FS, if you import FS, it's going to just work as if the whole FS module was the default export. If you try to import read file from FS, it will just work. This is magic that we're able to do internally. All of our internal core modules are still written using Common.js, but because we have a compilation step in Node itself, we're able to build out the modules in such a way that we have records that you can use the import syntax on them the way that you'd like to. ESM files need to use the .mjs extension. We'll dig into a little bit later about why we made those decisions, but if you want to write ESM and you want to import an ESM module, it needs to use the file extension .mjs. There is support for bare imports, so you can import a module just the way that you would in require. So if you npm install a module, and you could just install it by its name. And there's support for transparent interop and ESM, but no named exports. So what this means is you can import a Common.js module, but the Common.js module will only export a default. It won't export anything else. So you can't do like import series from async. It will blow up. But you can import async from async and then destructure that object, which, funny enough, is actually how a lot of the code we originally wrote in Babel was actually working under the hood. It was using destructuring and not proper named exports. This is kind of a confusing distinction we can dig into later. There's no support for transparent interop in Common.js, so you cannot require an ESM module. If you want to do that, you need to use dynamic import, which returns a promise, which will eventually resolve the module that you want. This is not the most ergonomic way to do things, but for lots of ways we'll get into later, it doesn't exactly work to move between an asynchronous to a synchronous to an asynchronous module loader. And hopefully, by the end of this talk, you know what that means. But as I said, there is support for dynamic import in both ESM and Common.js, so you can use the import statement in either and bring ESM modules that way. We also have support for import.meta. Import.meta is a stage 3 proposal at TC39, which is a place where runtimes are able to hang variables. So in Node, you're used to having a lot of lexically scoped variables. We wrap every single module. It's actually just a string concatenation, which is really easy to break. But every time you require something, the thing that you required is wrapped in a string that wraps it in an immediately invoked function expression that then in turn injects required, injects module, it injects dir name and file name. All those things that are kind of just available globally. It's actually just a little function wrapper. You can actually, if you write a Node module that just starts with one single quote and then closing that function, you can break Node in really weird ways. Don't do that. But some of our decisions made people grumpy. Some of our decisions may have made people in this audience grumpy. Some of these decisions may have made me grumpy. So, please wait. An explanation for all of this is currently loading. There's reasons for all of these decisions, and we're figuring it out. But let's talk about why we reached the decisions that we made in the module loader up until now. And to do that, we should probably just start talking about what is a loader. And a loader is a generic term for a workflow: fetch, transform, and evaluation hook. You need to first fetch all of the resources that you're going to load. You need to link them into a structure that will be executed, and then you need to execute that structure. When we discuss loaders in Node or on the web, or just in general when we're talking about ESM, it is these three phases. And one of the things that gets confusing is that Common.js does what's known as synchronous load and inline execution. It doesn't actually have these three distinct phases. When Node is executing code, the second it hits a require, it goes and fetches that file from the file system. It may try to fetch 5 or 6 files first because of how our specifier resolution algorithm works. But once it finds that file, it just starts executing it in line. And it just starts crawling that graph. So every time you hit a new require, it just starts executing new code. There's no load step. And this is actually how Babel originally implemented ESM. In early Babel, all it would do would actually take all of those import statements that you had, it would convert them into a require statement, and then it would convert that require statement into the inline text. And this is not the behavior that is specified by ESM. Babel has since fixed that. But this is one of those weird things that kind of creeps in and introduces inconsistencies in experience from, hey, like I wrote this code that transpiled, and now it actually doesn't run the way you were expecting it to. ESModules alternatively specify an asynchronous load and then a synchronous execution. And what this means is that we start by loading. We fetch the source text for all modules in the graph and resolve all the specifiers within all the source text. So we would start at the root, and we slowly find all the specifiers. We slowly resolve where all those specifiers point to, and we get all of the source text that's needed to create the graph. We then go into a link phase. And the link phase, for that, you must have the graph in memory, and it executes in a pre-order traversal, which means it starts at the root, and it moves then left and then right. So a quick diagram that I sketched up for this, we have a module that starts at the root. The root imports A and imports B, and the module A imports C and D. During the link phase, the first thing is going to be the root, then it's going to be A, then it's going to be C, then it's going to be D, and then it's going to be B. So this is the order that the link phase is going through the graph and building that representation in memory that can then be executed. We then move to the execution phase, which requires that that link phase be completed, and then executes the graph in a post-order traversal. And this is one of the places where things can actually get different between require and ESM. So same graph, but the post-order traversal now starts at C, then goes to D, then goes to A, then goes to B, and then finally goes to the root. And this is not necessarily the order that you would expect code to be executing at first, but it actually makes sense. If you import something and it's exporting symbols, you need that entire thing to have executed and exported the symbols before you could use it. So this post-order traversal is how code will always be executed and how that order will always be expected in ESM. Node has all sorts of weird dynamic ways that it can make this not guaranteed. But this guarantee of ESM is actually a really great thing for us to know the order of things. Now, I have a proposal at TC39 that is potentially going to destroy that order. Top level await could change that synchronous execution order guarantee. One of the things that we're talking about is if, for example, in this graph, A were to use top level await to dynamically import C and D, it would be possible that C could suspend and allow D to execute. But that's another talk for another day. The loader, though, is not specified. And this is where things start to get really interesting. The loader is left to be implemented by the embedder. So Chrome implements its own loader. Node implements its own loader. And the underlying mechanism of how that loader is implemented is left to us. But we do want to make code that can run in both environments. So this is where things start to get difficult because they're not interchangeable. We can't just take all the semantics of Common.js and apply them to ESM. And it can result in different execution order, as I was saying before. So this gets really frustrating. One of the things that we talked about in Node, for example, was if we made the fetch phase synchronous rather than asynchronous, we could guarantee the order in a different way that would allow us to have better interoperability between ESM and Common.js. But unfortunately, that would theoretically have us going against the spec or against the behavior of the browser. So, everything's a compromise here. And that specifier resolution that I've been talking about, too, is also different. TC39 similarly leaves it to the hosting environment to determine the resolution of how we resolve specifiers. So Node.js has a resolution algorithms for specifiers that many of you are probably familiar with. It supports bare imports. It knows to just look in the node.modules folder. It knows how to crawl the node.modules folder in package.jsons to find that particular module that you're trying to require. It allows you to import JSON. Isn't that nice? I love that feature. It allows for optional file extensions. So you can just import module, and then it will look for module.node, module.json, module.js, module.mjs. So it will kind of cycle through all the potential file extensions and eventually load it. And when this is coupled with the ability to import a directory by including an index.js file in it, it allows you to easily refactor between a file that slowly becomes a directory without requiring any changes to code. This is really, really nice user experience. We're going to start seeing a pattern here. Node has had the flexibility and ability to make a really great user experience without having to worry about interoperability with the web up until this point. But now we're at a point where the web is getting feature complete with Node on things, and we may have to dial back some of this user experience to ensure compatibility between environments. Because the web doesn't support bare imports today, for example. But there is a proposal for package name maps, potentially soon to be renamed module maps, which would allow for the browsers to support bare imports, deep traversal by file name, so being able to do a deep search into a module to grab specific files. But it doesn't allow for directory imports, and it makes the file extension is not able to be resolved for you. You don't have to have a file extension on a file. I mean, you can just import any path. A browser doesn't care about that. But it's not going to go through and resolve the file extensions for you. One of the main reasons for this is that you don't want to make 7 network requests to find one resource that you're trying to load. Now, it's possible that extensions to the package name map proposal could allow for things like optional file extensions or directory imports. But based on the current progress of that proposal, it's not looking likely. The package name map itself is a JSON file that lists the specifier and then a path to where that specifier resolves. There's a little bit more syntax to it than that, but that's kind of the small kernel of what it is. You would include it in a tag inside of your HTML in a link tag, and then any module, any code that you would execute afterwards would just know where these specifiers are. I think this is a really great example of influencing and shifting the browser towards the user experience that Node has had. But what you can notice here is we can't have all of the user experience that we've had up until now. So we kind of have this balance that we need to figure out in Node. Do we keep our legacy user experience that people are used to, that there's lots of really great programming patterns around? Or alternatively, do we pick a user experience that aligns closer to the browser to allow more code to be shared? Do we constrain the environment in a way to force patterns, or do we allow people to do whatever they want and allow the ecosystem to shake itself out? These are hard decisions that we need to make as a group. And even further, like to make things more confusing, the code actually executes differently in these environments to begin with. So they have different goals, which was something that I talked about before. And like the first time I heard goal, I was like, what? What's a goal? And we mentioned before that a goal is a combination of a top-level grammar and an execution environment. I'm going to name some goals, and then immediately you're going to know the definition of a goal. There's the script strict goal. There's the script sloppy goal. There's the ESModule goal and the Node.js goal. A goal is just a combination of particular grammar and the way that it's going to be executed. And there's ways to switch between particular goals. So there's in-band and out-of-band ways of doing this. So an out-of-band way, for example, is using MIME types. So in the browser, you can specify that a certain text, a .js file, is text JavaScript or text module. And by specifying that MIME type, the browser knows, oh, this JS file is this particular kind of thing. In Node, we don't have the ability of doing those kinds of out-of-band mechanisms. We don't have MIME types in Node. So we need to use file extensions. This is how we got towards MJS. Now, there's things like pragmas. So you can use strict, and that tells the runtime, hey, run this in the strict goal rather than running it in the sloppy goal. And that changes the semantics of the runtime a whole bunch. In the module goal, strict mode is turned on by default. which I think is pretty cool. But there isn't a ESModule pragma that we can use to distinguish that a .js file is in fact a module. There's a stage 1 proposal at TC39. It got opposition in the past. I'm thinking about bringing it back to the committee to just finally find out, hey, will this never happen, or can we get it to stage 2? But as it exists today, there's no actual way in Node to disambiguate the .js extension, which is why we settled on having an MJS extension, and that we would always need an MJS extension as an out-of-band way of being able to distinguish an ECMAScript module from a Node module, even if we find a way to solve other things with a pragma. I'm a fan of being explicit. You can maybe tell that due to my views on specifiers. But a little bit more into like what a top-level grammar is. Strict mode versus sloppy mode denoted with a pragma, as I said. And the module goal actually has a few more extra grammar changes on top of the strict mode. Specifically, you can't use HTML comments. It's possible that you just found out right this moment that you can use HTML comments inside of JavaScript. Sorry for letting you know that you can't use them anymore. Await is a reserved keyword. This is particularly important to me as someone who wants to see top-level await in the language. The fact that the committee held this as a reserved keyword was actually specifically so that top-level await could be discussed in the future, and was one of the things that helped me move a proposal forward. Those are the two major divergences, but it is possible that over time the module goal will divert even further from the strict and sloppy goal. Node, alternatively, is running in the sloppy mode by default unless you use strict. So just out of the box, Common.js and ESM actually execute complete with different semantics. And as I mentioned, ESModules don't have an in-source way of determining the goal, and that ambiguity causes real problems. There's also potential future goals, and this gets even weirder. So there's like a whole bunch of other things that .js could potentially mean, or other extensions that could come. So binary AST, which is a proposal that's being worked on by both Facebook and I believe Bloomberg is one of the other parties, would give us the ability of having a goal that could be imported of an already parsed abstract syntax tree to allow for much faster load times. I think Facebook was seeing something like 3 to 4% faster load times by just pre-parsing things into a binary AST. I'd be really excited about seeing binary AST as an intermediate format that different tools could use. But once we have that, now we have like a new extension, and this problem space expands. WebAssembly is another goal that we may eventually be able to import. And by eventually, I mean we will. People are working on that. So will you rely on it being .wasm when we come up with these specific things that we're doing? It's not just solving it once. We have to come up with solutions for many. A web package is another one, and HTML modules are another one. JSON modules are another potential goal as well. And when we're thinking about the solutions to this problem space, we're not only trying to solve the CJS and ESM interop problem, we're trying to solve the infinite potential future goals problem. How do we solve this in a reliable and robust way that works for all the potential edge cases that are coming down? Now, I don't think that these other goals that are coming through are going to try to like share the .js namespace. I think that that's particularly contentious because both ESM and Common and Script are all JavaScript, and no one's saying any of them aren't. So it gets really contentious about what we do with these file extensions, and you know, I can leave it at that. But so, you know, as I said, people were grumpy. That's an explanation of why we made those decisions. But what happened next? What did we do once we kind of got that feedback from people? We created a team. We created a modules team. We actually did an open sign-up. We tweeted about it. We told people. We just said, hey, literally all you need to do is put your name into this issue, and you can join this team. It was formed about 10 months ago. This is the initial commit in the repo where we started it. And some stats, right now we have 49 members in the team. There's representation from at least 10 countries from around the world. There's representation from at least 10 different corporate entities. So we've got not just a lot of representation for people from different communities and cultures, but people from different companies and different needs. We've also got key stakeholders from at least 14 different open source projects. Here's like the first batch of them. Here's the second batch of them. This was extremely important for us moving forward because a lot of these stakeholders didn't feel empowered in the original process. When we came up with those original requirements of the module loading system, people were upset. They weren't just upset because they didn't like the decisions, but they were upset because they didn't feel like they were listened to. And so one of the big things that we thought about with creating this large group is even if we reached a place where we came to the same conclusion, at least hopefully we could do it with more stakeholders in the room, and we could at least have people understand that like we're not trying to pull a fast one on them. We're not trying to not think about people's edge cases. It's just, this is a really hard calculus. And members of the team also participate in at least 3 standards bodies, including the TC39, the What Working Group, and the W3C. Despite what politics may exist with all these different groups, these are the 3 main groups that I believe are kind of driving forward the JavaScript language. And by having stakeholders from all of these places, we're able to figure out, like, you know, what bodies do we need to go to if there are changes that we need to make at a standards level. And most recently, what we've put together is what we're calling a minimal kernel. And this actually landed last week. I'm really excited about the progress that we made. And by progress, I mean all the things that we deleted. So it took us about 10 months to reach consensus on this. And it may seem like a small feat. But what we have done over time is create a subset of features. What are all of the things that we as a group agreed would exist in any potential iteration that we want to do? One of the biggest things that we found was problematic was there may be a feature that I want and a feature that someone else wants, and they preclude each other. So for example, I'm pretty adamant that I want to be able to import ESM modules with a .js extension, and I don't want to see transparent interoperability. I think that it's confusing, at least as it exists now, because there's no way to get named exports from Common.js modules. We have ways that we're working on that, but in the meantime, for the people who want to have transparent interoperability, for the people who don't want the JS extension to be ambiguous, those goals are completely not aligned, and I don't think there's a way that we'll ever reach consensus on that. So what we reached consensus on was this subset, and here's the feature set of it. You can only import ESM. There's no transparent interoperability. Those ESM files must have the .mjs extension. We recognize that this is a completely non-usable structure, but keep in mind, we're not shipping this kernel. This kernel is in a fork, and the only reason for having this kernel is for a starting place for all of our potential implementations to be built on top of. That way we can better share code and have a shared baseline. So we don't have pull requests that are removing things and then adding things. Everything that we should be doing now should be additive. There's no support for the Node.js specifier resolution algorithm. This not only includes file extension support, so there's no file extension sniffing, there's no importing directories, there's no even support for main. So while we do support bare imports by being able to import the thing from the node modules directory, you actually have to specify the endpoint, so we're not specifying main. You know, that may change, but this is it, really, for our first implementation in phase 1. So you may be asking about how do you do CJS interop. So we could still use ESM interop because we have support for dynamic import. So you can use dynamic import in Common.js to bring in ESModules. But this is what CJS interop looks like right now. You need to import create require path from module. You need to import file URL to path from URL. And then you need to call the create require function on the URL path that's been called on import meta URL. This looks like a failure of an API, but this is actually, in my personal opinion, one of our biggest successes right now, because we all hate this. and what the minimal kernel has started to show us is some really clear user experience gaps that are really easy for us to start to fill in. While we still have all these other contentious things that we can't agree upon, we can all agree upon, hey, like we want a non-transparent way to bring CJS in, and this isn't really ergonomic. And so that leads into phase 2. Where we're going to work on uncontentious features to enhance the user experience. We have this minimal kernel. We have a list of 4 or 5 different things that we think can be quickly enhanced to it. And these changes are going to, for the most part, be uncontentious. They're going to be, for the most part, things that we can potentially upstream back to the Node project, which will improve the current module implementation, and will be, for the most part, non-controversial. The next phase that we're focusing on is building extensible loaders and delivering an environment that allows for user-land experimentation. What this means, we want to create a platform for individuals in the user land to write their own loaders and to specify their own loaders. I have a vision of what this could look like, where in your package.json, you could have a specifier where you say, hey, this file extension, run this loader, and the loader would be some JS that would allow you to figure out what to do. A great example of where I think this could be great would be, how many people in the room use TypeScript? Wouldn't it be great to be able to just say, hey, for all TS files, use this TypeScript loader, and then you don't need to use TS Node anymore? You could use a Babel loader. You could use a Webpack loader. We want to create this extensible system so people can bring forward the user experiences that they want. Then the various people from the modules team could use this loader system to build out the kind of user experiences that we're expecting or hoping to have. Now, one of the biggest challenges here is going to be performance. Making these loaders performant will be hard, but that is one of the challenges that we'll be working on. And that will lead into phase 4, which is addressing the user feedback gathered from the experiments enabled by phase 3. The hope is that once we've created these loaders, once people have started playing with these loaders, we'll be able to see what people are doing, and from that, determine defaults that make people happy. Defaults that can help create a good ecosystem. I think a real hope that I have is in the same way that once we had the minimal kernel, there was a whole bunch of things that were way clearer than before because there was a lot of stuff out of the way. That once we have these loaders in place, a lot of kind of what to do next will fall in line. And you know, it's worth just mentioning as a closing note here, that whole group of people, we're all really hard at work to ensure that modules are a best-in-class experience for Node. I think the only reason why it's so contentious is because we all recognize that existential risk that we have here. If we get modules wrong, it could mean major ecosystem fracture. It could mean a Python 2, Python 3 type situation in the ecosystem itself. For myself, I see a huge risk that if Node drifts too far from the browser, it could be you know, kind of a note towards the end of Node. And when the risks are that high, tempers get high, and people double down, and people are not willing to budge. And so it's been really hard to kind of get to where we are, but it's only because we all care so much. I think that now that we've gotten this first bit of consensus together, that we've come up with this minimal kernel and a governance structure around working on it, that we're going to see a lot more progress in the coming months. I think one thing that we really want to see is something that we can ship by Node 12 that could work without a flag. And I'm hopeful that we'd be able to get there. And one of the nice things about the way that this has been designed, and because it's behind an experimental flag, is that it's very possible that we could have these things backported to 10 prior to 10's moving into maintenance mode. So with that, I just want to thank everyone so much for giving me your time. This is a surfing dog. Have a great day.